Alright, last section here for Algebra 1, Chapter 5, 5.7. Talk about scatter plots and trend lines. Okay, graphing's a big thing because we see data all the time in the newspapers or whatever. We've got graphing calculators. So a lot of what we do is looking at stuff that's graphic. It's easier to see and interpret. But what you'll see here and what we see in the real world is not everything comes out perfect. You don't get a straight line of points that you can draw a line through. You know, in the real world, things are different. They're not. You see trends, but you don't always see that exact straight line, and that's where the scatter plot comes in. So how do you write an equation to show trends in data? That's what the scatter plot does for us. Well, what is a scatter plot? It's a graph that relates two different sets of data by displaying them as ordered pairs. Okay? If you want to compare housing prices for the last 50 years, you could go back and find the average prices for each of those years, and you'll probably see that the price has gone up. Sometimes it's gone down, sometimes it's gone up. But what economists do with a lot of different sets of data is they try to look at a set trend and they try to put an equation to it. And that way they can try to interpret what's going to happen in the future. Okay? Those correlations could look like this. All right? If the data points tend to be the closer together they are, the better the correlation. And if they're going up over time, or depending on what you're doing, they're going up to the right, that's a positive correlation, because that would be a positive slope if we were drawing a line through it, if you recall what we did with slope earlier. Negative if the points are together and they're going down to the right, that's a negative correlation. And if the points are just all over the place, that means there's no correlation. There's nothing you can draw from that. The thing about here is you can draw a line in there and get a positive slope, negative slope, but where in the world would you draw a line when they're all scattered? Okay, you wouldn't, so there's no correlation. So how do we use this? Well, I took an example out of the book, example 2, page 365, and they want you to make a scatter plot with the information given. They're looking at pandas and the age of the pandas and their weights. Okay, this is how many months old they are and what they weighed in at. And you'll notice here when you plot the points, you see I've got ages in my X, my weight, my Y, weight in pounds, and when you plot the points, you can see here 1 month is 2.5, 2 months is 7.6, 3 months, 4 months. There's not a straight line that connects all the dots. Okay, it's scattered a little bit, but you can see the positive correlation, and you can see I've chosen 2 points to draw my line through, kind of to where there's kind of an equal amount of points on either side. Okay, just don't draw a line that would go here and where all the points are above it or all the points are below it. Kind of draw a line that goes through the middle of the points. So that's what I did. That's called a trend line. Okay? And you'll notice it continues out here. If I wanted to know, hey, what is the weight going to be roughly after 15 months? Well, I could come out here to 15, go up wherever I hit the line. Oh, it's, 75 pounds, whatever it might be. But that's what you do. You plot the points just like we've been plotting points. You'll see that they don't line up. You pick a line that kind of goes through the middle. I like to pick 2 points that I know, and I draw that line through them such that my line goes through the middle of the points. That's called the trend line. The question was also approximate the weight of a 7-month-old panda. Well, you can kind of pick a point in the middle here somewhere and kind of figure out where it would be, or look at your graph and kind of estimate it that way. Okay? The other way is to find the equation and check it. We find the equation just like we did in the last chapter. We've got 2 points off the line. I took 4 and 17.1. and 8 and 37.9. Okay? We find the slope first using y2 minus y1 over x2 minus x1. Nothing new there. I got a slope of 5.2. I took that slope, and you can take either point. I took the first one, 4 and 17.1. Just like we found an equation in the last video. I plug in my y, my m, my x. I multiply that together. I subtract it over. I get a b of negative 3.7. So here's my equation right here, with the slope that I found, with the points I used, and the b that I found using those points. Now, somebody else could have a line that's just a little different than yours, have an equation that's just a little different, but you're still going to get a positive slope, probably somewhere around 5, give or take, and a y-intercept somewhere in that vicinity there. But it all depends on the points that you pick. So this is an estimation, it's not exact. I plug in 7 months for my x, because the age was x in months. I plug it in for x, and I got 32.7 pounds. So you can see my approximation off the graph. You can see what I got with the line that I chose and the equation that I got from it. They're pretty close. Okay, they're similar. So plot points just like we have been. The only thing you're going to do different is you're going to draw a trend line in here kind of through the middle, and then take 2 points off that line and find the equation of the line just like we've been doing here for the last 2 chapters. And then you can plug in your, extend the question out. What will the weight be at 7 months? Estimated. Plug it in and there you go. Okay? Scatter plots. It's a way of taking real information and plotting it and seeing if there's a trend in what's going on, whether you're looking at economic things or whatever it might be. Age and the weight of an animal. And then you can find an equation to it, and then you can extrapolate and try to find different information using that equation that you found, or from looking at the graph. Okay? We're going to look at some examples of this tomorrow in class. We'll see you then. Have a good one. Bye.